In this presentation, we're going to look at a branch of descriptive statistics, which is measures of central tendency and measures of dispersion. Now, you will have already been familiar with measures of central tendency from GCSE Maths, but you probably didn't call it that. You will have called it averages. But all we're talking about is the mean, median, and mode. And our measures of dispersion, which measure how spread out our data is, so if all scores are very similar or if there's a big variation of scores. We have three types of those and they're used in pairs. So if you're using the mean, you'd use the standard deviation. If you're using the median, you'd use the interquartile range. And if you're using the mode, you'd use the range. So let's look now at measures of central tendency. I'm sure you all remember how to calculate these. So the mean is the statistical average. All you have to do is add all the scores up and divide it by however many scores you had. The median is the middle value, so you sort your data into order, and then the middle value is the median. Remember though, if you've got an even number of scores, then the median is calculated by taking the two middle values and dividing them by 2 to find the halfway point. And finally we have the mode, the most frequent. One thing to be careful about though is don't fall into the trap of saying if a data set has all different numbers that there isn't a mode. It doesn't mean that there isn't a mode, it means that all values are modal because they all occur equally frequently. Now in psychology, the one we use the most is the mean. You will often get a question though that will ask you when you'd use the median, and you'd use the median if there are outliers or anomalies which would adversely affect the value of the mean. So as well as knowing how to calculate the mean, median and mode, you need to be able to evaluate them as well. So let's think about the mean first of all. The strength is it takes account of all the values to calculate the average. It's the statistical average. The issue though is very small or very large values, what we call outliers or anomalies, can adversely affect the mean. When it comes to the median is useful because it's not affected by very large or very small values. So outliers and anomalies are not a problem. The problem with the median is if you've got a very large data set, it can be quite time consuming to sort them into order. But also if you've got an even number, by averaging the two middle numbers, the median value might not actually be a number in the original data set. Okay, so the mode then. So the mode is the only average that can be used if the data set is nominal. So if it's categories, for instance, the colour of cars in the car park, the only thing you can use is the mode. What's the most common colour? The issue with the mode is there can be more than one mode and all values can be modal, which means the mode is not always representative of the data. Okay, so that's measures of central tendency. Let's move on now to measures of dispersion. So measures of dispersion are looking at how typical your data is. So are all your scores very similar or are there wide variations? All of these things, in a way, measure the same thing. The less variation there is in the data, the smaller your standard deviation interquartile range or range will be. So standard deviation then, we'll use that with the mean and it measures how far on average each score is from the mean. So are all the scores pretty closely clustered around the mean or are they clustered at each end? If your standard deviation is small, then that means that most of your scores are very close to the mean. The interquartile range we use with the median. Now, if you think about the median, it's the 50th percentile in a set of data. So for the interquartile range, we measure from the 25th and the 75th percentile. So we basically just subtract the 25th percentile from the 75th percentile. It's very similar to the range, but if you think about what you do with the range, you just go from the lowest to the highest. So you subtract the lowest score from the highest. The key thing to remember is though, the smaller the number when you've calculated these things, the more similar the data set is. Just a little graphic to help you recognise this. So you can see the range, we're subtracting the lowest from the highest. The interquartile range, we're subtracting the 25th percentile from the 75th. And the standard deviation is calculating how far on average each score is from the mean. The scary one to calculate, because it's got a scary looking formula, but these formulas are never scary once you break them down, is the standard deviation. So to calculate it, we use this formula, but we work out the first bit, the sum of bit, the sigma sign, in a table to make it easy. N refers to the number of scores. Let's go through an example to break this down. If we've got a data set like that, so the first X is our data set, 6, 5, 1, 9, 8, 6, 6, 11, 9, 12. We've got 10 scores. If we add them up, we get an answer of 73. Divided by 10 means that our mean is 7.3. The next thing we have to do is take away the mean from the score. So 6 minus 7.3 is minus 1.3. 5 minus 7.3 minus 2.3, and so on. Now you can see that you've ended up with some negative answers and some positive answers. Now that's quite difficult to work with. So in order to make them all positive values, we square them, because I'm sure you remember from GCSE maths that a minus times a minus is a positive. So we go through and square them all. So minus 1.3 times minus 1.3 is 1.69, and so on. This is quite a laborious task, but it's not difficult because remember, you are allowed a calculator. We then add up those scores in that final column. So we've got sigma there. That Greek sign simply means sum of. If you see that, it just means total them up. So our answer is 92.1. We now need to substitute that value into our formula. So you can see we've done the top bit. So sigma, open brackets, x minus mean, close brackets squared. We've worked that out and we got 92.1. You'll remember we had 10 squares, so 10 minus 1 is 9. So 92.1 divided by 9 is 10.2333. The last bit is to find the square root of that. A nifty trick with your smartphones is if you turn them to landscape, it turns into a scientific calculator. So all you need to do is find the square root of 10.233 and it's 3.2. So our standard deviation there is 3.2. You'd always end up with two standard deviations, obviously, to compare. We've only done one example, but you'd be doing the standard deviation for each data set so you could compare it. Okay, let's have a look at an exam question. This was from the A-level specimen assessment materials. That's what SAM stands for. So we've got a question with a STEM. So the results table of means and standard deviations for the map reading scores of male and female motorists. So what do the mean and standard deviation values suggest about male and female performances in this investigation? It's 4 marks, so 2 for each bit, 2 for talking about the means, 2 for talking about the standard deviations. Remember, this is an AO2, an assessment objective 2 question, so you need to refer to that STEM. So if we look at the table, we can see that the mean for males was 15.4 and the mean for females was 5.25. So what does that suggest? Well, that suggests that in this study, males scored higher on map reading skills than females. And in fact, if you think about it, it looks like they scored on average 3 times higher because 5 goes into 15 3 times. If we look at the standard deviations, 2.7 and 2.22, they're actually very, very similar. So that tells us that the deviation or the variation in scores between males and females was actually very similar. So this answer would get full marks. The mean scores tell us that on average, the males were much better at reading maps than the females, as the score for males was approximately 3 times larger. Standard deviation scores are quite similar to each other, suggesting the spread of performances of the male participants and the female participants is similar within each group. Okay, I hope that's demystified measures of central tendency and measures of dispersion for you a little bit. Thank you for listening.